let's look at some work examples. So the last formula now it is your assignment to derive it. The same step that we follow, just follow it. The only thing is that the telescoping sum now will be the summation of 1 plus r raised to the power 5, because this is 4 now, minus r raised to the power 5 as r leads from 1 to n. So you're going to find your S1 and your S2. And what will be your S1? The S1 will be when you apply the limit, meaning you say let x equals to 1, let x equals to 2, and so forth. So you understand that the first will always cancel the second. For example, let's see something. When x is 1, you have 1 plus 1 is 2. So you have 2 to the 5th power now minus 1 to the 5th power, right? Then when x is 2, you have 1 plus 2 is 3 to the 5th power minus 2 to the 5th power. So you see the first term, we cancel the second term. So that's the pattern that will continue. The first will always cancel the second term for this telescoping sum. And then the next one now what you need to do is to expand this one for your S2. Then you equate the two of them. And then you factorize, you get your final answer. So let's apply these formulas. So the first problem says the summation of 3r minus 2 as r now leads from 4 to 8. So let's apply these formulas. Now the first one I'm going to take one. Let's take one. Let's make r to be 1. The only way you can apply these formulas when your index of summation begins with 1. Because you see, in all of the formulas, r begins with 1, the index of summation. Now, the index of summation doesn't only have to be r. It can be any other variable, but it must begin with 1, and it must end with some other number, right? It will be n, it will be a particular number that is known, and just any other number. But it must begin with n, with 1. So if we look here, we can only use the formula for this one. We cannot use the formula here. Now, also for this one, we cannot also use the formula here because it is not in these forms. So we cannot use the formula here. We can use the formula right here. We can use the formula here. We can use the formula here also. We can use it here. We cannot use it here. We cannot use it here. We can use it here. And we can also use it right here. So we do the first problem. So the ones that we cannot use the formula on, we will directly find their sum. So now, for this one now, we have this to be equal to the summation of 3r as r now leads from 1 to 8 minus the summation of 2 as r leads from 1 to 8. So we bring this number behind the summation of r as r leads from 1 to 8 minus the summation of a constant. It just equals to the constant times the upper bound. So it's just 2 times 8. So for this now we bring in this one, which is 3. The summation of r, where is it? Now this is r, this is not n. The summation of r is just equals to n times n plus 1 all over 2 minus 2 times 8 now is 16. But now what is n? N is equals to 8. So therefore, we have our n now to be 3 times 8, 8 plus 1 all over 2 minus 16. So 8 plus 1 now, in fact, let's reduce this one. 2 here, 1 times 2 into 8, it goes there 4 times. So we will have 3 times 4 is 12. 8 plus 1 now is 9 minus 16. So it's 12 times 9. 9 times 2 now is 9 times 2 is 18. You get rid of 1. 9 times 1 is 9, plus 1, 10. So it's 108 minus 16. So 108 now minus 16. This is now 2, right? And then 10 minus 1 is 9. So this whole thing is just equals to 92. So this sum now is 92. Now I'm going to do question number 4. So for question 2, question 3, those are problems that you can easily solve right from the previous class. So you can just replace this R now in there. In the first one, the first term, you will just have 3 times 3 plus 2, plus the second term now will be 4 times 4 plus 2. The third term will be 5 times 5 plus 2, and the last term will be 6 times 6 plus 2. Then now you can find the sum. So for this one, you have J. The first one will be 3 raised to the power 1 plus 1. The second one will be 3 raised to the power 2 plus 1. And the third one, 3 plus 1, the fourth one, 4 plus 1, and so forth. So let's do this one, question 4. So we have this now to be equal to cos of par, let's say k par. K now begins from 0, 0 par. So it's 0 par plus cos of, from 0 go to 1 par, plus cos of, from there we go to 2 par, from there we go to now 3 par, cos of 3 par, from there we also go to 4 par, plus cos of 4 par, from there we go to 5 par, plus cos of 5 par, from there 6 par, cos of 6 par, cos of 7 par, and cos of 8 par. Now, remember now that par is equal to 180 degrees. This is 0 degrees, is 360 degrees. This is now 180 degrees, right? This is 90 degrees. This is 270. So 180 degree angles that are formed with the x-axis, they are related to cosine. Those ones that are formed with the y-axis are related to sine. That is to say, cos of 0 degree is positive 1 because it's on this side, and then cos of 180 degree is minus 1 from the unit cycle. Now, sine of 0 degree is 0, and then sine of 180 degree is also 0 because it is on this line. Sine is not on this line. Sine is associated with this line. So now, let's continue. So if we move all the way here, we will have 2 par. Right? We will have 2 par. If we go all the way and come back here, we will have 3 par. We come here, we have 4 par, just like that. So take note. So the first one, you have cos of 0. So cos of 0 now will just be equals to 1. Cos of 0 now is just 1. Positive 1. Plus cos of par. Cos of par is minus 1, right? It is par minus 1. Cos of 2 par. 2 par is right here, it's positive 1. Cos of 3 par. 3 par falls right here, right? So when the coefficient is odd, cos of par gives us negative. When the coefficient is even, it gives us positive, right? So even negative, that's an odd negative, even positive from what we are seeing here, right? So cos of par is negative. Cos of 2 par is positive. Cos of 3 par will be negative 1. Cos of 4 par will be positive 1. Cos of 5 par will be negative 1. Cos of 6 par will be positive 1. Cos of 7 par will be negative 1. And cos of 8 par will be positive 1. So let's do the cancellation. This carry this out. This carry this out. This carry this out. This carry this out. What are you left with? You're left with positive 1. So it means the sum for this now is just positive 1. Now let's do question number 8. So question number 8 now, we can first expand this one, right? So let's bring it down right here. We have the summation of r times r is r squared times this one is r cubed. R times 2 is 2r times this one is 2r squared. 1 times r is r times this one is r squared. And 1 times 2 is 2 times this is 2r. R is from 1 to n. So we can take the summation of each term. So the summation of r cubed as r is from 1 to n plus the summation of 2r squared. So we can factor out the 2 and write the summation of r squared as r is from 1 to n plus, now what will also happen between here? 2r squared plus r squared now just give us 3r squared. So between here now the sum could just be 3r squared. So instead of writing it twice, we just say this 3r squared. Then plus now we factor out the 2 also. 2 comes outside. So this now just gives us the summation of r as r leads from 1 to n. So we can bring in each of these formulas. So what is the summation of r cubed? R cubed is n plus 1 all over 2 raised to the second power plus 3r squared. R squared now is just n plus 1, 2n plus 1 all over 6 plus 2r n times n plus 1 all over 4. Now 4 bar. Is it 2? Yes, 2. So 2 cancel 2. 3 here 1 times 3 into this 2 times. So now we simplify it. So after this question 8, we're going to do question 11. The rest of them now will be left for you to practice. So now we have, we simplify that. We expand this thing, right? That is n squared and n plus 1 all squared divided by 4 plus n times 2n times n is 2n cubed. N times 1 is n times this one is n squared. And then 1 times 2n times n is 2n squared. 1 times n is n. Right? Each of them must be expressed over 2. Plus the last one there, you have n times n is n squared plus n times 1 is n. We expand this one, you have n squared now times n plus 1, n plus 1. So let's do that quickly. N times n is n squared, n times 1 is now n. 1 times n is n, 1 times 1 is 1. Length between here. So this whole thing now will be n squared plus 2n plus 1. Each of them must be expressed over 4. Over 4. Plus 2 and 2 will go out. You just have n cubed. This is plus n squared now over n. 2 and 2 will also go out. You have n squared. Erasing this one. So this one now is plus n over 2 plus n squared plus n. So we can get rid of the denominator by finding the least common denominator. So we just write this one, these ones, all of them expressed over 1. So we find the least common denominator between 4 now, and there's no and here is 2. Between 4 now and 2, the least common denominator is 4. So we multiply 4 by every term. So 4 times n squared is 4n squared over 4. 4 times n squared again, 4n squared over 4. 4 times 2 is 8n over 4. 4 times 1, right, is now 4 over 4. 4 times n cubed is 4n cubed over 1. 4 times n squared is 4n squared over 2. 4 times n squared is 4n squared over 1. 4 times n is 4n over 2. And 4 times n squared is 4n squared over 1. Plus 4 times n again is 4n over 1. So now we further simplify. What happens? 4 and 4 go out. 4 and 4 go out. 4 here 1 times 4 into this 2 times. 4 and 4 is just 1. This is 1 and this is 2. This is now 1, this is 2. So finally now we can have n squared plus n squared, right, plus 2n plus 1 plus 4n cubed plus 2n squared plus 4n squared plus 2n plus 4n squared plus 4n. All of the like terms, these are all like terms. So all of the ones with n cubed, so we have 4n cubed is the only term, right? The next one we have n squared. So you have 1, 2, 3, 4, 5, 6, 7, 8. So you have plus 8n squared. Go to n. 2, 4, 6. So we have plus 6n. Plus the number is just 1, right? You have plus 1. So that's just it. Hi guys, welcome back to class. So we have the next problem to solve, question 11. So we want to find the summation of k squared times k squared minus k plus 1. So the first thing we need to do is to first multiply this k squared that is out by every term in there. So we have the summation of k squared times k squared is k to the 4th power because we add the powers, minus k squared times k to the 1st power is k to the 3rd power, plus k squared times 1 is just k, as k leads from 1 to some n. So the next thing we do, we take the summation of each term. So we take the summation of k to the 4th power, as k leads from 1 to n, plus we take the summation of, now this is minus now, k to the 3rd power, as k leads from 1 to n, and then we have the summation of k as k leads from 1 to n. So bring in a formula for each of these expressions. K to the 4th power is the same as r to the 4th power, because we told you that the variable is a dummy variable. So in that case, any other variable can represent these variables. So k down to the 4th power is the same as saying r to the 4th power. So r to the 4th power just equals to this expression. So therefore, we write that expression n times n plus 1 times 2n plus 1 times 3n squared plus 3n minus 1, all divided by 30. This is now the summation of k squared, k to the 4th power as k leads from 1 to n. This is it. Minus the summation of k cubed as k leads from 1 to n is just equals to the summation of r cubed, which is now n plus 1 raised to, that's a divided by 2, and all raised to the 2nd power. Plus the summation of k. The summation of k is the same as the summation of r. So that is n plus 1 all over 2. Now, so what we need to do is that we need to get rid of the denominator. The entire fraction, we want to get rid of this fraction. So in getting rid of these denominators, let's first ensure that we know the actual denominator right here by getting rid of this power. So that is to say we have n plus 1, so that we just multiply the first two. N times n is now n squared. N times 1 is now n times, so that we multiply this and this. 2n times 3n squared is 6n to the 3rd. 2n times 3n is 6n to the 2nd. 2n times minus 1 is minus 2n. So 1 multiplied by this is just the same thing, 3n squared plus 3n minus 1. So this whole thing should be divided by 30. Minus. So everything in here must be multiplied 2 times. So this n must be multiplied 2 times, is n squared. This n plus 1 must be multiplied 2 times, n plus 1 times n plus 1. And then this 2 should be multiplied 2 times, and it will just give us 4. Plus n times n is n squared, n times 1 is n all over 2. So we can simplify further in here. You have 6n squared, you have 3n squared, you have minus 2n, you have positive 3n. So n squared now plus n times 6n cubed. Now positive 6n squared plus 3n squared is 9n squared plus n, because minus 2 plus 3 is just plus n. You take 2 from in 3. Minus 1. Minus, so we multiply. N times n is n squared times n squared is n to the 4th. N times 1 is n times this n is n to the 3rd. 1 times n is n times n squared is n to the 3rd. 1 times 1 is 1 times n squared is just n squared. So if you look between here, these two are like terms. 1n cubed plus 1n cubed, they just give us 3n cubed. Now put this in parentheses because of this negative sign. All divided by 4 plus n to the 2nd power n all over 2. Now this whole thing now is 30. So at this point, let's get rid of the denominator. So we can find the least common denominator for 30, 40, that's a 34 and 2. Can 4 go into 30? This 2 can go into 4, this 2 can also go into 30. So even if we select 30 as our least common denominator, 2 can go into 30, 30 can go into itself, but 4 cannot go into 30. So let's double this 30. If we double this 30, we have 60. Can 4 go into 60? Yes. 4 goes into 60 15 times. So we say our LCD is 60. So we just multiply this whole thing by 60. We multiply this entire thing by 60. So what we're going to do now is that we're going to say 60 times this entire fraction, this first fraction. Now you have 1, 2, and 3 fractions, right? So 60 times this first fraction. So it will be 60 multiplied by the entire fraction, which is now n squared plus n times 6n cubed plus 9n squared plus n minus 1, all divided by 30. We finish with the first fraction. Then we move to the second fraction, 60 times the second fraction. So you will just have 60. You put the 60 outside. Then here you have n to the fourth plus 3n cubed plus n squared. All divided by 4. Then lastly, we say 60 times the last fraction. You just have 60 times n squared plus n all over 2. Now you have multiplied 60 by every term in this expression. So now we reduce it. Now the reason why we did not multiply this 60 by everything in here is because we want to reduce the denominator here and this 60 so that the denominator can go out. So let's reduce it now. We have 30 into itself 1 times, 30 into 60 2 times. So it is just 2 now we're going to multiply by the entire numerator. 4 into itself 1 times, 4 into 6 1 times. Remember 2, we added 2 on the 0, it makes it 20. 4 into 20 5 times. So 4 now into 60, it goes there 15 times. Now so the next one now we say 2 into itself 1 times, 2 into 30 into 60, it goes there 30 times. So now it is just 2 now we're going to multiply by the entire numerator. So let's go ahead. N squared times 6n cubed. You add the powers of the variables. So it's 5. So now 2 times 6, it just gave us 12. Right? Then n squared times n to the third power, it gives us n to the fifth power. Now n squared times 9n squared is 9n to the fourth power. 9 times 2 is 18. N to the fourth power. N squared times n is n cubed times 2 is 2n cubed. Minus n squared times 1 times negative 1 is negative n squared times 2 is negative 2n squared. We finish multiplying the first term by everything. We move to the next term. N times 6n cubed is 6n to the fourth times this 2 is 12n to the fourth. N times 9n squared is 9n cubed times 2 is 18n cubed. N times n is n squared times 2 is 2n squared. N times negative 1 is negative n times 2 is negative 2n. We finish with the first one, right? We move to the second one. So it's 15 times n to the fourth power. Now, this negative must affect everything in there, right? So it's 15n to the fourth power. 15 times 3. 15 plus 15 is 30. Plus another 15 is 45. So 15 times 3 now is 45. 45n to the third power. 15 times n squared is just 16, 15n squared. Then 30 times n squared is 30n squared. And 30 times n is 30n. So we look for like terms. So I'm going to cycle the ones that are aligned. Now this is, I'll use a green marker. N to the fifth power. We check as to whether there is n to the fifth power we do not have. We move to the next one, n to the fourth. N to the fourth. We check for n to the fourth. N to the fourth. That's all. Then we move to the third power. This n to the third. N to the third. N to the third. Those are the ones with n to the third. So we're going to cycle n to the second. N to the second with green marker. N to the second. n to the second, n to the second. Then the n now is just this one, this one. So let's do it now. So the first one, 12n to the fifth, we read 12n to the fifth down. It has no other like term. Move to n to the fourth. So you have 18 minus 2. Let's say minus 18 plus 12, they are like terms. What else again? Minus 15, because you have 1, 2, and 3. So it's 18 plus 12. So 18 plus 12, 10, 20, 30 is 30. So 30 now minus 15. You left with 15, positive 15. So you have positive 15 n to the fourth power. We move to n to the third power. 2n cubed plus 18n cubed. This gives us 20n cubed. Minus 45n cubed. So it's like you have to take 20 from 45, which will be left with 25. So it's negative 25n cubed. So we now go to n squared. So n squared now, you have minus 2n squared plus 2n squared. This and this go out. Which one again? Minus 30 plus, let's say minus 15 plus 30. It gives us positive 15n squared. And then what else again? We move to n to the first power, minus 2n plus 30n. So you subtract 2 from in 30, you have positive 28 because the greatest number is 30. Positive 28n. So this is our final answer. If you like, you can factor out n. N is common to all of the terms. So we can bring it outside. We're left with 12 here. N to the fourth now, we're subtracting 1 here from here. The next one, 15. N to the third minus 25. N to the second plus 15. N to the first plus 28. So this is now our final answer.